morning everyone. I am Tanushree of Civil Engineering branch, and today I am going to teach you Module 1 paper which name is Structural Mechanics. So in the last class we learned about various kinds of beams, various kinds of support and loading condition in case of beam. So now today we will discuss about the shear force and bending moment calculation of a cantilever beam with a point load at the free end of the beam. So I told you in the last class what do you mean by a cantilever beam. That is the beam having a fixed support at one end and it will free at another end. Okay, you can see here is a fixed support and here it is free end of the cantilever beam. So in case of the free end, it is provided by a point load which is denoted as W. Okay. So how we will calculate the shear force and bending moment, and after that we have to draw the shear force diagram. As you can see, this is the shear force diagram. Then below the shear force diagram, we have to draw the bending moment diagram as per the calculation. So first of all, the shear force diagram is the graphical representation of the variation of shear force along the length of the beam and is abbreviated as SFD. So we can say that the shear force diagram as SFD, as well as we can say the bending moment diagram as BMD. So let's start the calculation part. So first one is your shear force calculation. So in case of shear force definition, I told you whenever we have to calculate the shear force, we have to draw a XX section, cut section. You can say a cut section. According to the load, we can provide the section at the left side or the right side, as we can provide as per our suitability. So because the loading system is here, so we draw the diagram at here, and the cut section distance from the free end we take as X. So first of all, we have to assume or consider a XX cut section at a distance of X from the free end of the cantilever beam. Okay. So now comes to the first calculation of the shear force. So here, first of all, we have to take two cases. The first case is where L equal to X, that means your length equal to X, which is the distance from the free end to the cut section of XX, and another distance we have to take in the second case, which is L equal to L, that means length equal to total length of the beam span. Okay, so we have to calculate from the right side to the left side, that means in this direction we have to calculate. Okay, so first of all, we have to take L equal to X, as I said. So it is the first case. So I told you in the first class, while the section is here and the condition of the loading system right side and downward in nature, then we will take the sign of the shear force as positive. So just look at the figure. See, if this is the cut section and the beam is provided with a downward direction load at the right side of the section, then your sign will be positive. So here also we have to take the sign of the shear force as positive because it is right side of the section and downward in nature. So your load is provided as W. So what will be the load or what will be the shear force? It is W, and the unit of the shear force is kilonewton. So we can write the shear force of the XX section, that is Fx equal to W kilonewton, and in bracket we have to define the positive sign due to the right side of the section and downward in direction of the loading. Okay, so this is your case 1. So comes to case 2. So in case of case 2, we have to take the L equal to or the length equal to total length of the beam, which is given as L. So here we will take L equal to L. Okay, that means length equal to L. So while we calculating from the right side to the left side, so we reach at the fixed end support. So we can say that the shear force at the fixed end of the cantilever is equal to W. Why? Because you can see in the total span of the cantilever, only one load is acting. Okay, without this load, any kind of loading condition is not provided. So that this W loading or this point load only act on the whole span of the beam. So that this load is continuing up to the end of the beam. Okay, so that at the end or at the fixed end of the cantilever, the shear force will unchanged. So the shear force at the fixed end of the cantilever equal to W kilonewton, which is again positive because it is right side of the section and downward in direction. So your shear force calculation is completed. So according to the shear force, we have to draw the shear force diagram. So as we found out the shear force as W at the XX section, that means here, and again W at the here. So it is linear in nature. So that's why we got a point of the shear force here and again at the fixed support here. Okay. So first of all, while we draw a shear force diagram, we have to draw first of all a reference line. Like you can see here, the lower line of this shear force diagram is the reference line. Okay. Then after that, we have to detect the point of the shear force. So here 1W and another shear force is here. So after that, we have to join this point and make a beautiful diagram of the shear force diagram. Okay. So because it is positive in sign, so we have to detect the positive sign here. Okay. So now comes to the bending moment diagram. So in case of bending moment, you can see here also two types of case. First one is your length equal to X and second one is your length equal to total length of the beam. So the first case, that means the distance from the free end to the cut section. Okay. So now you know that the moment equal to force into distance. So we have a force of W kilonewton and the distance is X. So what will be the bending moment value? It will be W which is x. So W into x is the right answer for case 1. So you can see the bending moment at x-axis section is W into x. But here is negative sign. Why? Because you can see due to this downward loading system, it will give a moment like this. Okay. So if it will give this kind of moment, we know that if the moment is in downward direction, then the moment is known as hogging moment, which is negative in nature. So that we will provide the negative sign over here. Okay. So in bracket, you have to write the negative sign due to hogging moment. So your case 1 is over. So now comes to case 2, which is the length of the beam we have to consider. That means the total length of the beam, which is L, and your loading system is again W. Okay. So now we have to consider this loading system and the distance from here to fixed end support. So now we will provide again same formula, that is load into distance. So your load is W and distance is L. So by multiplying these two, we got W into L. Okay. So again, the bending moment at fixed end of the beam is minus W into L. So here also the sign is negative because again the loading system is downward, and due to the downward loading system, the moment is provided as hogging moment. Okay. So this one is your case 2 result, which is minus WL. So in this way, your bending moment calculation also over. So according to the bending moment, we have to draw the bending moment diagram. So now see, at the point of the loading system, here the value of bending moment is 0 because here only load is there, no distance is there. Okay. But our moment equal to load into distance. So here W is there, but the distance equal to 0. So that at the free end of the cantilever, the bending moment value is 0. Then come to the x-axis section. So we got the value at the x-axis section, the bending moment equal to W into x. Okay. And again, at the fixed end support, the bending moment we got minus WL. So because it is negative in sign, so while we draw the bending moment diagram, first of all, we have to draw a reference line. As you can see, the upper line of this diagram is a reference line, this one. Okay. So due to the negative sign, we have to draw the bending moment diagram towards the downside of the reference line. So you can see we got a point here and another point here. So obviously your WL will greater than the WX value, so that we got the point over here. So by joining all these points to the reference point, we got a triangular section of the bending moment diagram. As like this, due to the linear value of the shear force, we got a rectangular shape of the shear force diagram. So in this way, your shear force and bending moment calculation of a cantilever beam with a point load at the free end is over. So today this much. We will discuss another derivation of the shear force and bending moment in the next class. Thank you.